where thyristor bridge rectifier is required, and that is supplied by 230 volt, 50 hertz supply. Okay, let's say T1, T2, T3, T4. So in this circuit, we have to find out the power factor. So can anybody let me know what should be the procedure to find out the power factor in this kind of circuit? Anybody? Okay, so power factor is what in terms of like how it is lagging, how the current waveform is lagging from the voltage waveform, right? So, but generally in power electronic circuit, there are so many components of current. One is fundamental, on which we rely upon, which can give us the active power in majority. And other is like harmonic component of fundamental, let's say third harmonics, fifth harmonics, and so on. So power factor is the angle between V1 and IS1. This is known as fundamental power factor, or you can say uh, that cos alpha it is known as. That depends upon the firing angle. And the input power factor, uh, which is defined with uh, is the angle between Vs and Is. Okay, with Vs1 and Is1, that is known as fundamental power factor and or distortion power factor, and this actual power factor of overall circuit with overall or total component of voltage and current, that is known as your total input power factor, right? So we were asked this one, and this firing angle was provided in the problem. I hope you are able to see the firing angle provided in the problem, that is 30 degree. And it is also mentioned that it is delivering a constant DC current in the load, that is of 10 ampere. Okay, so this was the thing here. And after that, uh, I will draw some waveform of voltage and current so that you will be able to visualize the waveforms, and then you can identify easily what kind of waveform and what kind of lagging or leading is it. Yeah. So voltage is anyway sinusoidal. So Vs is equal to Vs1. There is no harmonic component. So that is the advantage of sinusoidal voltage. And its magnitude is 230 volt RMS, means 230 root 2 volt of peak amplitude. And this will be pi. Okay. Now, after some firing angle, let's say this circuit you are seeing here, and alpha was given 30 degree. So at 30 degree, T1 and T2 will be turned on. At 30 degree, T1 and T2 will be turned on, and this load would be in forward connection, right? Like this. T1 and T2 is on. T1 and T2 would be on. And here, like load would be connected and current would flow. Okay. So in this manner, this T1 and T2 will flow, and the power, but this forward current, this Is is positive. Let us assume this direction is positive. So this current is positive for this half. Let me identify this alpha, and if this current is positive and this voltage is directly connected to supply, if we can see here, there are nothing inductance or capacitance or anything else. So this V0 would be equal to Vs from alpha to whatever point this T1 and T2 would conduct. Okay. So it will start conducting from alpha, and it will conduct till pi. This was pi. This was 2 pi. At least it will conduct till pi. In problem, it is said that it is delivering constant DC current of 10 ampere. Okay. So the current of constant DC of 10 ampere, it means there is no discontinuous conduction in the circuit, and hence uh, this T1 and T2 would continue to conduct pi plus 30 degree. And after that point, this T2 and T3 and T4 will take over, and T1 and T2 would be in reverse biased, and it will get turned off. So from alpha to pi plus alpha, this is the voltage waveform of output, and this is kind of voltage waveform. Now, uh, we had to calculate the waveform of this IS. Fine. So for calculating the waveform of IS, we all know IS could be in two form. Either it could be I naught or minus I naught. Why? Because this load is directly connected to supply. When T1 and T2 would conduct, this current will flow in this manner, T1, T2, and it will connect the load in this manner. When T3 and T4 would conduct, so again T3, T4, you can see the thin line, thin red line. Okay. So it will flow in this manner, right? So that would contribute minus I naught because its direction would be the opposite of this load, right? So that's the concept here. If you see, the current is going in this direction, this direction. Earlier it was going in this direction. So that's the fundamental here. I hope you are able to catch it. If any doubt, you can stop me in between.
Sir, sir,
Yeah,
small doubt, sir.
yeah. Please go ahead.
Sir, can explain, sir, that's diagram?
This diagram, a circuit diagram, you are asking?
Yes,
Okay.
circuit diagram.
Huh. See, when T1 and T2 was conducting, so the current direction from this load side, current direction will be from A to B. Let me denote from plus to minus, right? And this would be same, irrespective of supply current getting reversed or not. For blue one, I have drawn the blue connection for T1 and T2, right? And for conduction of T1 and T2, this current direction was like this. It is getting in similar with I naught. But when T3 and T4 would be in forward conduction mode, then what will happen? You see this
Sir,
conduction.
sir, sir,
Hmm.
sir,
Yeah. Please.
sir, sir, T1 direction, up direction, down direction.
T1 is up direction, na? Let me show you. T1 is in this
Yes,
this
sir.
direction. T1. The conduction happens from anode to cathode, right? From A to
Can you
K.
repeat again?
Yeah.
Can you repeat again?
Any current will flow in thyristor from anode to cathode.
Diagram.
So this is anode, this is cathode. So current will flow from anode to cathode from T1, and similarly in similar manner in T2, right? In T2 also it will flow in this manner. It will go in this manner. Are you able to follow this? Let me draw once again. Let me rub this.
Sir, 1 second, sir, repeat again.
Yeah, I am repeating again. Let me erase the earlier part so that I will be able to show the current direction again. See, if T1 and T2 is conducting, then current direction would be this. You agree till this point? Gangadhar, you were asking, you agree till this point?
Yes, sir.
Huh. So
Sir, మళ్ళీ ఒకసారి రిపీట్ again, sir. Signal is not connected.
okay,
Can
okay,
you
okay.
repeat
Sir,
again, sir?
Yeah, sure. Yeah.
sir,
Anybody else is asking? Anubhav, yeah. Go ahead.
yes, sir. Please explain the concept to us. He just create nuances control class also.
Can you repeat it? I did not get that point.
Sir, please explain it to us and then explain to him because
Okay.
he
Okay. So, Gangadhar, what is happening? Your connection is low. So anyway, I will put this recording session in on my YouTube channel. So you can access from there, or you can go to NPTEL Gate website. You can access it from there as well. Is it fine, Gangadhar? Yeah. So I hope so. It would be fine for you. So I was telling that this could be the waveform of V naught and it will repeat for other thyristor, or sorry, other cycle in similar manner. Any doubt till this point? Now, the time is to show the current waveform of IS, right? IS will be always I naught, and this was I naught. And when T1 and T2 was conducting, IS will be equal to I naught, right? From alpha to pi plus alpha, that alpha is 30 degree given in the problem. And after that, when T3 and T4 was conducting, then IS is equal to minus I naught. If you identify the current direction here, T3 and T4, it would be opposite of I naught. So let me draw this from alpha to pi plus alpha, and in similar manner for other part as well. So this is a square wave diagram which would consist several harmonics of fundamental component, and that fundamental component will also have some contribution, and I would say that would contribute majorly in any power electronics converter, and it should contribute majorly because that is the point of using any DC to AC or AC to DC converter. So uh, this blue one, what you are observing, this is IS1. Okay, this is IS1, and this VS is anyway sinusoidal, and IS1 I have shown you how you can obtain a sinusoidal waveform from a square waveform, and you can easily observe that phase difference between these two waveforms is alpha, right? Here alpha, this much phase difference between these two. So this is fundamental displacement angle, or we can say the phase difference between fundamental component of voltage and current, that is alpha, and that is also called as fundamental power factor. So this cos alpha is 30 degree, but we need to find out the angle between Vs and Is, and if you add all the components of Is, so one factor which is known as distortion factor, that would get multiplied with this power factor. This is known as G, and this
Sir,
total
can I repeat again, sir? That graph.
uh, Gangadhar, I guess you have a weaker signal at your end. So what I suggest you, I will upload this session
Yes,
of
sir. Signal
recording.
is
Uh, Gangadhar, you can watch this session on YouTube. Recording will be available. I think your signal is very weak. So you try to
yes, sir. Weak only, sir. Signal is weak.
yeah. So on YouTube, it will not be any problem. So you can catch up from there because others will be got
Yes,
behind
sir.
you.
Can explain, sir, that
earlier also in the book
Yeah.
was trying to say that he create motions in other classes as well. So just like
Yes.
with disturbance.
Okay, okay. So,
Yes,
please, Gangadhar, you stay muted, please, because others are getting disturbed. You can access this session from YouTube. I hope it would be okay for you. So, I am moving ahead. So, the total input power factor would be multiplied with G. Why G? I will explain. And what is G? That also I will explain. See, IS1 and IS, there should be a relationship between these two current because both is the component of single entity, that is source current. And IS1 would be always less than IS because it is a part of IS. So there is one factor defined to relate the ratio between IS1 and IS, and that is called as distortion factor. G, this is distortion factor. Okay,
IS1 is a fundamental component of I.
fundamental. This blue one you can see from the graph, and IS is the red one, which you can see from the graph.
Yes.
Yeah, fine. So earlier our power factor angle between VS and IS1. Anyway, VS and VS1 is same, but it was contributing to cos alpha. Now I need VS1 and IS. The angle would be same with one factor. How? This IS is equal to, you can see IS1 by G, or the relation with distortion factor. That's why this G factor is getting multiplied here. Any doubt till this point? If not, then I will move ahead and I will try
yes,
to.
sir. Please explain this again.
Okay,
Why
this.
we multiply G?
See, earlier this alpha was the angle between VS1 and IS1, but we need a relationship between VS and IS, right? So there is a relationship between IS1 and IS. This is the relationship between IS1 and IS. So putting, we are moving from IS1 to IS. So we need one factor like uh, how to put it, we need one factor that will be accumulated to the power factor formula. So that factor would be G. And G is nothing but the relationship between IS1 and IS. Am I getting through?
Yes, sir.
Okay, thanks. So that was the reason to introduce this G. G is nothing, it is the ratio between fundamental and total. That's it. So how will we calculate G? That is another point. And at the end, I will tell you what is the shortcut. There is always a shortcut for such kind of problem. That is known as, you might have also seen that power factor is equal to G times cos alpha. And G for this type of problem, for single phase full wave converter, G is nothing but 2 root 2 by pi. This kind of values people used to mug up, but I will show how it is coming like that. So IS1 is the sinusoidal one, and if you see this, how to calculate the Fourier series of this square wave. So let me show you this I note. So IS would be summation of n is equal to 135 to infinity 4 I naught by n pi, 4 I naught by n phi sine n omega t minus n alpha. So why I am writing this expression? So if there is any square waveform, I am just telling you a shortcut. You can either derive it from concept of Fourier series. So But in power electronics, I believe that if you know Fourier series of one or two kind of waveform, you will be easily get through all types of problem because you will majorly see a square wave because the work of power electronics is to provide a sinusoidal thing, but that fails in that purpose. So it kind of tends to provide us a square waveform. So anywhere you can see that. Or maybe at some point of time, I would take one session on like simplification of this kind of series, this kind of waveform, where you can just, uh, there would be some tricks or ways to calculate the Fourier series. But I think you would be aware for this kind of a square waveform, the peak value magnitude of a square waveform that is multiplied by 4 by n pi sine omega t. But since it is shifted by alpha angle, that's why, and it is shifted towards right. So sorry, it should be plus, right? No, minus only. So I am using this concept from signal and system. If it is shifted rightwards, so it would be minus. So that's why n alpha would multiplied. And anyway, alpha would not contribute in calculating the factor of g. But this kind of waveform, you can easily derive such kind of Fourier series. Any issue till this point? So, and if I move ahead and I will try to compute IS1 RMS and IS RMS. So first I will try to write what will be IS1, and IS1 would be 4I naught by 1 into pi, because n will be 1 sine omega t minus alpha. And if I will try to take this RMS one, so IS1 RMS would be 4I naught by pi, and for calculating RMS, we will divide it by root 2. So it will come out to be 2 root 2 by pi I naught. Any doubt this till this point?
No.
Fine, thanks. So IS1 RMS we calculated. Now we need to calculate IS RMS, right? And IS RMS for the square waveform, you would easily calculate because if you square this, so this will become I naught square and omega t. Let me tell you. IS RMS is equal to 1 by t IS square d omega t from alpha to pi plus alpha. We can take 2 by t because it is periodic anyway. So you can take this way, or you can also write like 1 by t. Since this is a half wave symmetric, so we can easily go for half period. Otherwise, you can write from alpha to 2 pi plus.
Alpha to pi plus alpha is equal to 1 by t by 2. So it means 2 by t.
Yeah,
Half.
for half time. Yeah, you are correct. Huh? But when I am doing from alpha to 2 pi plus alpha, you can take one full cycle. Doesn't
Yes.
matter. Huh? You are right. Huh? So since it is half wave symmetry, so I will further simplify it from alpha to pi plus alpha and IS square, and that is nothing but if you do a square for this portion, it is already I naught. If you square this negative term, it will also become positive and it will again become I naught. So I naught square will be for throughout the period. So that will be I naught square d omega t. And after solving it, you will get d omega t. If you do it, 2 by t, I naught square is constant. So let me take it side. And d omega t, if you integrate from pi plus alpha minus alpha, and it will become pi, and t is anyway 2 pi, so 2 by 2 pi would get cancelled out. This term would get cancelled out with this term, and it will become I naught. So that will be your IS RMS. Any doubt? I don't think so. It should be, but you can ask. So we calculated IS1 RMS and IS RMS, and Now we need to take the ratio between them, and if you calculate the ratio between them, so this would be IS1 RMS by IS RMS. So IS1 RMS was 2 root 2 by pi I naught, 2 root 2 by pi I naught, and that is IS1 RMS divided by IS RMS is I naught. So I naught and I naught get cancelled, and G will become 2 root 2 by pi. So this will be your distortion factor for this problem. That's why I told this waveform is quite a common across the single phase rectifier or single phase inverter, you can say, and hence this value would be very common in your gate problem. So if you remember, it's well and good. It could save you 1 or 2 minutes in exam. Otherwise, you always approach from a standard rule. So I hope it was fine till this point, and final answer I would calculate here. So final answer would be cos phi, that was G cos alpha, and G was 2 root 2 by pi into cos 30, and that would come out to be, yeah, that will come out to be 0.78. So it would be answer to the problem. So it was asked for 2 marks in GATE 2016 in session 1.